Okay. Good morning, everyone, and welcome to this first session of ICPLP, the first conference on phantom limb pain. The first session is a workshop presented, a workshop on bodily illusion is presented by Dr. Marta Matamala-Gomez, Tony Donegan, and Dr. Justyna Swidrak. Welcome all, and now I give the work to them.
Okay, thank you, Eva, for your presentation. And I'm going to share my screen. Okay, so good morning, everyone, and thank you for being here in our workshop that is entitled Body Illusions for Phantom Limb Pain Relief. I'm a postdoctoral, currently a postdoctoral researcher in the University of Milano-Bicocca, and together I was working together with Justyna and Tony in Barcelona in the Event Lab laboratory. It's a laboratory that is specialized in the use of virtual body ownership illusions and virtual reality in overall. And the three of us have experience in using these virtual body ownership illusions in clinical applications, and especially in patients suffering from chronic pain. So we thought that it could be an interesting idea to make this workshop for this conference. So here it is an outline of the workshop. And I will start introducing the concepts of and definitions of body illusions, showing which types of body illusions, how can we use, how can we induce body illusions. And then my colleagues will show you some applied clinical studies using these types of body illusions, and in specific body ownership illusions for pain reliefs in patients with phantom limb pain. So first, I would like to remember this film that was launched in 2009 that is called Avatar, in which a paraplegic Marine has called to a mission to save the world, and he has to travel to another planet called Pandora. And to travel to this planet, he has to use a computer interface, and when he was inside this computer interface, he could feel full embodied in an avatar body that has different physical characteristics of his physical body. And also, when he has embodied in this avatar, he could do different things, such as running or fighting with his avatar body. So this is the concept that we want to introduce today. So how can we use these body illusions through an avatar or through fake bodies to change or to improve a damaged part of the body of patients with phantom limb pain in this case, but overall for clinical applications? How can we induce these body illusions to feel the patient that his body has been recovered? So now I will introduce the concept of body illusions. So when we talk about body illusions, we refer to an altered perceptual states of the body, inducing an illusion of a new body that differs physically the configuration of our own body. And this difference could be in terms of size, as in the avatar in the film. The avatar is a tall avatar, a super big avatar. It has different shape because it's like someone from another planet, and has also a different color of the skin because it's blue. And he has also different posture, and it is placed in a different location because it is in another planet. but still the people can have this sense of ownership toward the fake body or the virtual or the avatar body. So this is the definition of body illusion, when we can alter our perception to perceive that another body is our own body. So as probably most of you know here in this workshop, the perception of the body relies on multisensory integration. That is, every day, different sensory signals are arriving to our body. And these different sensory signals are integrated in our brain, in the temporoparietal junction in the brain, and where we have some neurons that integrate all this sensory information arriving to our body to give us a coherent representation of the environment, but also a coherent representation of our body. So thanks to this multisensory integration that is happening in our brain, we can know that this is our body, I'm touching my body, and I don't know, this is a table, and we can recognize things as we know. So the thing is that when there are some alterations in this multisensory integration, the perception of our body and also the perception of the surrounding environment can change. This has been shown, for example, in these studies from the group of Blanke and colleagues, where he found that that some patients with brain injuries in this area, in the temporoparietal junction, and also healthy patients in which they stimulated this specific area, experienced some body illusions of the body because there is an alteration in this area that it was integrating all this sensory information. So when the multisensory integration is altered, people can experience body illusions. In this case, people experience it out-of-body experiences. That is a type of body illusion in which people feel outside of the body, and they can observe their own body from another perspective and also the environment from another different perspective. So manipulating this multisensory integration, the sensory stimuli arriving to our body, we are able to change the representation of our body, and we can induce different types of body illusions. There are kinesthetic body illusions, out-of-body experiences, but in this workshop we will focus in the body ownership illusions. And one of the most known examples of the body ownership illusion is the rubber hand illusion, a study that was conducted by Botvinnik and Cohen in the 1998, in which they induced a multisensory conflict between the vision and the tactile sensory stimuli. So I will show you this video in which you clearly will show this effect. In this video, the researcher was stimulating the real and a fake arm, that is a rubber arm, and the real hand of the participant is out of the field of the vision of the participant. The researcher is applying tactile stimulation, synchrony in the same place and at the same time. And then when the researcher tried to hold the rubber hand, the participants react realistically to that event. So this happens because they felt ownership toward the rubber hand. So the researchers induced a body ownership illusion toward the rubber hand. In this case, they changed the perception of their own body. So as we saw in the video, we can induce in multisensory conflicts body ownership illusions towards fake body parts, and also toward whole fake bodies. In this workshop, we focalize more in body parts, but it is possible to induce it towards whole fake bodies. And as I said before, this body ownership illusions relies on establishing a connection between the real body part and a fake bodily shaped object via multisensory stimulation. Moreover, when we induce this body ownership illusion, this has an influence also in our physiological responses, our behavioral responses, and also in the cognition of the subject. So our brain adapts to the the configuration of the body to this new perception of the body, but also our whole system adapts to this new fake body. So, and this happens. There is a concept that explains this connection between the body image and the body representation in the brain and the changes in physiological and behavioral responses. That is the body matrix concept. This concept that was introduced by Mosley and colleagues in 2012 and illustrates that there is an interrelationship between the cognitive representation of the body in the brain and also the homeostatic functions, that is physiological responses, behavioral, and the cognition of the subjects. So the body matrix is considered a high-level representation of the self in the surrounded environment, which is able to integrate the different bodily signals and sensory stimuli from the directly surrounding environment in a coherent body-centered framework. And then when there are changes in this body matrix, in this body matrix, so if body representation changes, changes also our conceptual belief, our cognition, the body adapts to these changes because it's all connected. So following this, according to this statement, it has been shown that some patients with presenting some clinical conditions such as chronic pain, but also patients with anorexia nervosa, psychiatric pathologies, and neurological disorders experienced some alterations in the body representation and also in the body matrix. So an injury in our nervous system can induce these alterations in body representations. So there are also a large number of studies that have been shown that there is a link between the body image and in the case of pain and pain responses. And this link is bidirectional, showing that there is a top-down body effect of body image in pain perception. And this is also relevant for patients with phantom limb pain. Especially in patients with phantom limb pain, it has been shown that after the amputation, there is because of the sensory interruption, because of the amputation of the limb, there are some maladaptive plasticity changes in the brain. So there is a maladaptive brain map reorganization of the brain. That means that the area in the brain that was representing the amputated limb is moved to another brain regions in the brain representing other areas, and this could induce pain perception, the phantom limb pain perception. This is one of the concepts introduced in the literature about the phantom limb pain. But also there is others that says that the preserved representation of the amputated limb in the brain after the amputation can also induce this phantom limb pain, and this could be because sometimes the representation of the limb persists in the brain after the amputation, but it is represented in a distorted position. So in the case of patients, amputee patients experiencing this telescoping effect with in which the amputated limb is shrinked, or the hand is directed to the elbow and is placed in distorted positions. So the thing is, how can we use body ownership illusions to normalize these distorted positions? How can we do believe the patients that the distorted representation of his body is normalized? So, as there are a large number of studies demonstrating that we can induce these distortions happening in clinical populations through the use of body ownership illusions, through rubber hands, through virtual reality, we can manipulate the perception of the body and reproduce these distortions in healthy subjects. we can do the opposite effect. So we can use these body ownership illusions in clinical populations to normalize the distorted representation of the body. And this is the idea. And this normalization, we expect, and some evidence demonstrate that this normalization of the altered representation of the body after the injury or after the amputation may have an impact in the perception of pain in this case. So for this, there are also, I want to show you these review studies in which they argue that the use of body ownership illusions through mirrors, through rubber hands, and also with new technological developments such as virtual reality or augmented reality, by using these mechanisms, we can induce pain relief, and we can normalize this maladaptive plasticity, and also modulate the distorted representation of the amputee limb in the brain, or the distorted representation of the damaged part of the body in the brain. So here I will show you the three main body ownership illusions that are currently used in clinical population. The most used is the mirror box illusion, and the rubber hand illusion. It was also used, but in less studies. And now is the virtual arm illusion or virtual body ownership illusions are growing up in the research field. So now my colleagues, my colleague Justyna will talk more in depth about the mirror box illusion, about the rubber hand illusion studies in patients with suffering from phantom limb pain. And at the end, my colleague Tony will talk in detail about the different studies using virtual arm illusion or virtual body ownership illusions. Here you have the reference list, and maybe later we can send our slides to see it with more calm. And thank you for your attention. In the bottom of the slides, you have my email if you have any questions, and that's all. Thank you for your attention.
Okay, now my turn. Let me share my screen. My name is Justyna Swidrak, and I am a postdoctoral researcher in the event lab group in IDIBAPS, and assistant professor at the Institute of Psychology in Polish Academy of Sciences. I'm a psychologist by training. Marta has already explained what is the rubber hand illusion. I will start my part of the workshop by showing how research and treatment, how it is used in research and treatment. First study that I will talk about demonstrated that rubber hand illusion can be evoked in amputees. As you can see in the first picture, the stump was hidden under a table, and synchronous brush strokes were applied to the stump and the index finger of the rubber hand placed in front of the participant. After experiencing the illusion, the participant was asked to demonstrate where he or she had felt the touches by pointing along the ruler with their eyes closed. And the rubber hand was also stabbed with a needle while measuring participants' skin conductance as the objective measure of strength of the illusion. And the results show that rubber hand illusion can be induced in upper limb amputees by simultaneously touching the stump and the finger of the prosthesis, and that here you can see that the skin conductance in the synchronous condition was higher, which is an objective measure of the ownership. And interestingly, the shorter the time period since amputation, the greater was the illusion. But overall, the illusion in most amputees was much weaker and less vivid than the traditional rubber hand illusion. Importantly, in traditional rubber hand paradigm, participants never experience the fake hand as a supernumerary limb. So the point is that participants feel ownership over the rubber hand and don't feel ownership of the normal healthy limb. The only exception is when they are presented with two artificial hands. And in that case, and in this study I will describe briefly, it was not always the case. Here, participants were positioned at a mirror box with a rubber lamp placed, as you can see here, so that the mirror reflection was superimposed upon the hidden phantom behind the mirror, as seen in this picture. Participants then fixated upon the mirror reflection of the rubber hand, while stimulus objects touched the rubber hand only, so this one. And 3 participants out of 14 upper limb amputees reported self-attribution of the rubber limb in the mirror, in addition to the existing phantom limb. So they felt they have the ownership over both. And they all indicated somatomotor similarities between the rubber limb and their prior paretic limb, with both feeling numb and with limited movement. And importantly, the actual limb has been paralyzed for 2-3 years before amputation, which means that they experienced before a lack of sense of agency. So perhaps that's why it felt, it gave them this extra feeling of ownership over the rubber hand. And this study proves that rubber hand illusion can be a useful paradigm for investigating the mechanism of body ownership, body presentation in amputees. But it has also limitations, as we can see in a study that was published this year on 4 participants of amputation. We know that enabling sensory feedback in limb prostheses can reverse a damaged body image caused by amputation. And in a study where 4 patients participated who have neuromusculoskeletal prostheses with neural sensory feedback, these 4 patients turned out to be immune to. Here you can see the design, how it was induced. There was these patients tend to be immune to rubber hand illusion for both of the prosthesis and the unhealthy limb. And in the interviews, it turned out that the prosthesis felt as part of their body in their daily activities, and that they felt very strong ownership, and that it felt as part of their body. So this result explains that sometimes people immune to rubber hand can nevertheless experience ownership over prosthetic limbs when used in daily life, and it means that the results of the laboratory experiments are not always that relevant, or cannot be used cannot lead to far-fetching implications for real-life applications. So that's why we can say that it can be an interesting paradigm to study body ownership in amputees, but it cannot be always useful. I will move to mirror therapy, which I'm pretty sure most of the audience knows. I will mainly focus on the evidence for its efficiency in phantom limb pain compared to other types of intervention. I will start with a brief demonstration for those of you who are not familiar with this intervention, how mirror therapy is done.
Okay, I'm Jeremy McVeigh, Doctor of Physical Therapy, and this is the mirror box therapy that we have used for people with CRPS, RSD, after stroke, or amputation. That can be used in any number of with any number of injuries. So what we would start with is we'll take the involved hand and put it into the closed side of the box, and we'll take the non-involved hand and put it into the side where we would see the mirror, and then lean toward the side so that we could see both hands looking the same. And then we're going to visualize on that to start out with, so we might just concentrate on this for a period of time and then build from there to actually doing motions like pronation, supination, making a fist coming out, touching each digit, and slowly building up what we would do to including other things, even desensitization, where we might have some popcorn peanuts or something in the box and doing that, actually putting pressure on the bottom of the box and moving both at the same time. So you can see that it's important that you have a high quality mirror and that that we are building the things that we're doing. We wouldn't want to increase the symptoms, especially in CRPS. So that's a brief demonstration of what we do and what it is. Thanks.
Okay, a bit of history. The pioneers of the mirror therapy were Ramachandran and Roger Ramachandran, who published their first papers on the topic in 1995 and 1996. And in these studies, these were case studies, they reported that patients who used the mirror therapy for 3 months, 15 minutes per day, felt lasting pain reduction, and some patients who reported clenching spasms, with just a feeling that the nails were digging into the phantom, felt immediate relief and analgesia after the treatment. And here you can see also the original picture from the study. As you can see, that the technology did not change much. It's still used in the same way. In 2007, the first RCT study was published for the lower limb amputees, and 10 years later, it was replicated for the upper limb amputees. In both studies, there were 3 groups of patients. Patients in mirror group attempted to perform movements as you could see in the video, with a mirror reflecting the image of their limb. Patients in a covered mirror group did the same, but the mirror was covered with an opaque sheet. And patients in the mental visualization group were closing their eyes and imagining performing movements with the amputated limb. The results of the first study showed clear evidence for the mirror therapy as being more efficient than the other 2 conditions, and in that case, after switching, when the patients from the control conditions switched to mirror therapy, they also reported a significant decrease in pain and in pain intensity and duration. The same was repeated in 2017, where basically the same setup was used, and the controls switched after 11 treatments after 11 sessions to the mirror therapy, because it was the only one that was efficiently reducing pain. Interestingly, the response to treatment after 5 days of the mirror therapy largely predicted the response at the end of the therapy, showing that it can be quite early known whether a patient reacts well or not, because there are individual differences. Not all patients react well, but on average, it seems to be relatively efficient. There are some limitations, as I mentioned. Foyle and colleagues investigated the effect of daily mirror training over 4 weeks in 13 chronic phantom limb pain patients, and they found out that the patients who experienced the telescopic distortions profited less from the treatment, with almost no pain reduction, as you can see in the figure, this blue line. While this group of patients, the group of patients without the telescopic distortion, was experiencing significant pain reduction. And this suggests that experienced body appearance is an important predictor of mirror treatment effectiveness. On the bright side, mirror therapy was, in an RCT study, mirror therapy was found to efficiently reduce pain and improve psychological well-being of patients, which is not that often included in studies. I think that was the first study where they measured it with questionnaires, and that was compared with phantom exercises group. So both were efficient, but mirror therapy was more efficient. A recently conducted systematic review and meta-analysis of published RCT studies for neurotherapy confirmed that there is a fair evidence in favor of the therapy compared to control conditions. As you can see, the top forest plot shows the evidence in favor of neurotherapy in almost all studies besides one after 3 months of treatment, and the bottom one shows the evidence in long-term effect. So it seems some studies it was a really big effect. In some it was closer to 0, but still on the average shows that it was efficient more than the control conditions. There was also 5 years ago there was a systematic review and meta-analysis showing that describing existing at that time evidence for various bodily illusions efficiency on clinical pain reduction, and it turned out that the most consistent evidence was for pain decrease after 4 to 6 weeks of mirror therapy, while there was no effect on pain after only 1 session of mirror therapy. So it shows that it has to be a repeated intervention, cannot be just 1 session. There's limited evidence to suggest that bodily illusions can alter pain, but some illusions, namely mirror therapy, bodily resizing, and use of functional prosthesis shows therapeutic promise. This is the conclusion of the authors. Conclusions from this part of the workshop will be that the rubber hand illusion is used to study phantom limb pain mechanism, but its application for treatment is limited. And the mirror therapy is a cost-efficient and simple tool for phantom limb pain reduction. Moreover, there is a fair evidence for its efficiency, but more research is needed to better understand and maximize the analgesic effect, especially the individual differences and why some patients react very well and some others don't, and how to make it work basically for more bigger groups of patients. There is evidence supporting the theory that phantom limb pain is generated in part by a mismatch between the visual and proprioceptive inputs, and that mirror neurons activation may contribute to the success of mirror therapy by modulating somatosensory input and pain perception in the phantom limb pain. Nonetheless, I have this feeling that there is still a lot more research needed to really understand in depth the mechanism behind mirror therapy efficiency, and in general of these effects. Here is the bibliography, my email address in case somebody wants to contact me. And now I will give the floor to my colleague Tony, who will tell about studies which use virtual and augmented reality for phantom limb pain. Thank you.
Just share my screen. Okay, good morning, everyone. Thank you to Marta and Justyna, and thanks to the organizing committee to let us present this workshop. My name's Tony Donegan. I'm a physiotherapist with a specialist interest in chronic pain, and I'm currently studying a doctorate in the use of virtual embodiment to manage and treat chronic pain conditions and for rehabilitation. So my bias is very pro VR, but when I'm trying to review the evidence, as I'll do, I'll try and be as fair and objective as possible. Some concepts first. I mean, some of the potential advantages of VR and AR generally are that we can do unilateral movements, so we don't have to rely on the contralateral limb like we do in mirror therapy. We can use stump movements, we can use stump EMG, we can even use brain-computer interfaces to drive the movements of a virtual limb. VR, we can gamify and make it really engaging. We can give patients targets and goals, and that may help to improve enjoyment and adherence. it allows us to take a graded therapy approach. So for example, with very kinesiophobic patients, we could start with just simple passive observation of the moving virtual limb and then work our way towards more actively generated movements. And finally, and probably key to sort of my research interests are, we can give you a virtual body in virtual reality that can be felt and is experienced as your own, and you can explore that in virtual environment with your new virtual body. So this is a concept that came about over 10 years ago now when Mel Slater at the University of Barcelona reproduced the rubber hand illusion using virtual reality with congruent visuo-tactile stimulation. And this also works with visuo-motor, congruent visuo-motor stimulation. So with motion tracking, if you move your real limb and your movements of your virtual limb are matched, you can experience ownership and agency over that body, especially when it's experienced from a first-person perspective. So we're talking about putting on a head-mounted display and looking down and seeing a virtual body that moves with your body, and that when something touches your virtual body, you feel it on your real body. You start to embody, have the illusion of owning that virtual body. The great thing about VR is that we can then manipulate that virtual body however we like. We can resize it, we can shrink it or make it grow or shrink or stretch it. We can make it change color. You know, limitless changes you could do to this virtual body, and it can still be felt and experienced as your own. For phantom limb pain specifically, for example, we could even match the patient's phantom. So, and then we could change it. So often phantoms are in quite anatomically implausible positions, or they may be in painful positions. Justyna gave the example of the fist being clenched with the nails digging into the palm. If we match that in VR and then show it normalizing, is that therapeutic? Perhaps, we don't know, but you can perhaps see the potential there. We know that these types of body manipulations are analgesic in painful populations, and we wrote a review on this a couple of years ago, but it's not really been specifically studied yet in phantom limb. So if we look at the evidence for VR interventions more generally, if we start at the top of the evidence pyramid and look at systematic reviews, there's really only this one from 2018, which looked at mirror therapy, motor imagery, and VR together. And at the time, only 12 studies met the inclusion criteria, and only 2 of those were VR studies, both small case series. So we've no RCTs. Both gave positive results for reducing pain, perhaps unsurprisingly, but neither of these studies was immersive VR using the HMD. So neither utilized actually virtual embodiment. They were using stump EMG or stump movements to drive the movement of a virtual limb on a 2-dimensional screen. If we cast our net a little wider and don't worry so much about the methodological quality, we can pick up some more small case series and a couple of qualitative studies, but really very, very little out there in terms of VR interventions in phantom limb. Now, all of these show positive results on pain. Importantly as well, there's no adverse effects. There's minimal sort of dizziness or motion sickness. So it seems to be feasible, safe, and well tolerated in clinical populations. Now, the limitations of these reviews and these studies identified are clearly there's no control. So we're unable to separate the distraction effect of VR. It's a novel therapy. There's a powerful distraction effect that can be analgesic, and Hunter Hoffman's VR studies have shown this in acute pain situations really well over the last 20 years. And there's no direct comparison with mirror therapy. So the cost of VR setups is coming down dramatically, but it's still not as cheap as a mirror box. So, you know, to be clinically usable, you have to show that it's significantly better than mirror therapy. Really small studies, so they're likely underpowered, and a really wide variety in the type of interventions and the type of patients that we see. So we're not able to meta-analyze these very well. It's really unclear about the long-term benefits and the optimal dosage as well. And these probably suffer from publication bias. So, you know, you're never going to see a case study or a case series with negative results being published, unfortunately. So it's only the positive ones that get published. So there's likely to be some publication bias. If we fast forward a little bit to later in 2018, this was a really large multi-center, well-conducted RCT that explored the use of mirror therapy and augmented reality mirror therapy. So they had 75 unilateral lower limb amputees, and they randomized into 3 interventions. So the 2 groups had 4 weeks of mirror therapy, supervised mirror therapy. Then the first group had a home-based augmented reality treatment. So they had they took over an iPad. The iPad, the webcam and the iPad reproduced and flipped the image of their leg when they looked down. So it's essentially an augmented reality mirror therapy using the iPad as a mirror. The second group did traditional mirror therapy, and the control group just did sensory-motor exercises for the intact limb. And they measured pain outcomes at 4, 10, and 24 weeks at 6 months. And the results were actually pretty disappointing. There was no differences between the groups at 4 and 10 weeks. And at 6 months, the duration of phantom limb pain episodes had improved, but not the pain intensity or frequency. So the authors concluded that the results don't favor either mirror therapy or augmented reality as a viable treatment for phantom limb. Now this, certainly for mirror therapy, would contradict some previous RCTs on mirror therapy, as Justyna discussed. I think it's probably a little bit unfair to dismiss augmented and virtual reality just on the basis of this study, because this is basically augmented reality mirror therapy. You're using the iPad as a mirror. So it's in 2 dimensions. There's no real embodiment of the limb, I would argue. It wasn't measured, but we can see how that's pretty unlikely, I think. The authors did identify some subgroups that may have responded better. So females, patients with telescoping, which again is unusual and contrasts the FOEL study that Justyna mentioned, and patients with a motor component to their phantom limb. So no RCTs and no good systematic review evidence. So we have to kind of come further down the evidence pyramid, and we come to sort of case theories. Now, if we look first at non-immersive VR studies, and this is where patients can control a virtual limb seen on a 2-dimensional screen. And there's been a few of these published, and I'm sure that they're familiar to many of you. So you can use stump movements to drive the movement of that virtual limb, and even stump EMG with the phantom motor execution. And we'll probably hear more about that over the next few days. I think there's actually a forthcoming randomized controlled trial on that. So, and also brain-computer interfaces. So this recently published paper used magnetoencephalography to drive the movement of a virtual limb on a screen. Now, all these studies show highly clinically significant improvements in pain of greater than 30%. The case series are limited, again, by small sample size, an absence of randomization and controls, and a reliance on the trial therapist to collect data. So we need RCT data, and as I say, that's forthcoming. But the final point is that this is looking at the avatar on a 2-dimensional screen as a third person. There may be agency over that movement, but there's probably not true body ownership, I would argue. So to get true body ownership, we need to use immersive VR with a head-mounted display like you see here. And not many studies have done this with phantom limb pain, and really only at a proof of concept exploratory sort of stage. So this was a nice feasibility study where they took a physical cycler and they mapped those movements to virtual reality. So there was visuo-motor congruence. So they had 14 phantom limb pain patients, or patients with phantom limb pain, but 7 upper limb, 7 lower limb. And obviously the VR enables visualization of the intact virtual limb in motion. And they evaluated changes in pain sensations, unpleasant phantom limb sensations, and other feasibility aspects. And what they found was pretty cool. I mean, the unpleasant phantom sensations you can see reduced to almost nothing immediately after the intervention, and a moderate reduction in pain as well. So preliminary results suggest this might be therapeutically very useful. Another nice study, another case series of just 2 lower limb amputees, and here they used inertial sensors on the stump and the intact limb to power virtual robotic legs, as you can see in the so again, fully immersive VR, and they're playing several customized games. So the 2 patients experienced immediate post-session pain relief, as you can see, but also a gradual reduction over the course of 3 sessions. Now, obviously, with this, we don't know whether that analgesia is a distraction effect of the VR or the effect of the body ownership. It's likely to be a combination of the 2. I think what's promising is the gradual reduction over the 3 sessions. So if we want to improve embodiment of the virtual limb, we said we can do that with visuo-motor or visuo-tactile feedback, but with a phantom limb, how do you apply tactile feedback to a phantom limb? Well, you can actually do it through the cheek, through using referred sensation. And this was a nice study that did exactly that. So they took 9 participants with phantom limb pain, and their intact limb was mirrored and used, transferred over to the other side in VR, and they had to touch a target, touch a ball. And when they touched the ball, they experienced a vibration stimulus. So that vibration stimulus was either experienced on the cheek or directly to the intact hand, or there was no tactile feedback. And they compared the 3 conditions and their effect on pain intensity. And what they found was that there was significantly more pain reduction in the cheek condition. So the analgesic effect of the intervention was improved by applying tactile feedback to the cheek on the affected side. So I would argue that's probably greater embodiment of that virtual limb. So future work, where are we going with this? I think mirror therapy and non-immersive VR are probably a step ahead. We have RCT evidence. It's slightly contradictory, and we may need to start taking more of a subgrouping approach and starting to see if we can identify certain subgroups that will respond better. For a fully immersive VR and embodiment studies, we're a step behind. I think we're still at the proof of concept and feasibility stage, because hopefully, as I've outlined, there's not a lot of information out there. But I think 3 important questions that need answering. If we maximize embodiment in VR, does that increase the analgesic effect of bodily illusions? So if we experience a virtual body from a first-person perspective and apply this congruent multisensory stimulation, how analgesic is that? If we repeat those non-immersive third-person VR studies, is there additional benefit? So if you're using stump EMG or stump movements to drive a fully embodied virtual limb seen from a first-person perspective, is that additionally analgesic compared to viewing it from the third person? So that would be really interesting. And finally, does altering the appearance of the virtual limb have an analgesic effect? Does resizing it, does matching and changing the position and appearance of the phantom? And again, all this work still needs to be. But hopefully I've convinced you that there's enormous therapeutic potential. And that's me. So there's my reference list. And thank you very much for your attention.
Thank you so much for your introduction on bodily illusions, and we have some questions for you. So we have a Slido just for everybody that started late on the screen. That is sly.do and then the numbers 635252. I repeat, 635252. And there you can ask questions for all the talks today, and we will also collect them so we can forward them to our experts during the panel discussions later on. And we start with the most pressing questions because there were multiple people that were wondering about clinical implementation. And where do we have that one? Here. Do you see any challenges in translating virtual reality treatment to the clinic? And if so, which challenges do you see?
Okay, so Tony wants to, who is answering? Do you want to answer? Start answering and then mine.
I think the major problem right now is probably cost and sort of programming expertise, which, you know, this is pretty resource intensive stuff at the moment. It's lab-based stuff. So if there were a way to utilize sort of commercially available VR hardware and software, and convert that to something low cost, I think if we could do that, then the sort of clinical application would probably take off. I think that's the major challenge at the moment, is how can we get this out into the clinical environment, because costs have come down enormously over the last 10-15 years for VR headset. It used to be tens of thousands of pounds for a VR setup. Now you can pick up a VR headset for less than 300 euros. But that still leaves the problem of the software and the programming that's required. So yeah, for me, that's the biggest challenge, I think.
Yeah, these are maybe that is connected with the programming challenges, to create a full embodied virtual illusions, no? The virtual body ownership illusions through the whole body, to increase the embodiment perception, and also to be able to really manipulate the body representation of the clinical populations, and as more embodied you can induce to the patients, more effective could be the treatment in clinical outcomes, in pain rehabilitation, but also in motor rehabilitation and in other types of psychiatric rehabilitation also. So this is the challenging thing, to create full embodied applications in virtual reality. It's very complicated because of the programming and also because of the setups, because we have also, well, people is innovating now in these head-mounted displays to be more portable, and so on. But yeah, I agree.
Okay, thank you very much. And I think the next question tags right along on this topic, and where one of the viewers is wondering, do you see any advantages of using AR over VR? So, and then a follow-up question, could it create a stronger ownership illusion as you are in your usual environment and not in a digital one?
I want to take that. I mean, off the top of my head, I think probably the advantage of AR is that it's more portable and more functional. You can, well, maybe not yet, but soon you'll be able to walk around the streets with an AR setup. You can't really do that in VR. It's pretty dangerous. So yeah, from a functionality point of view, I can see AR having advantages over VR.
Yeah. I would add that also, I mean, everyone has an AR device in the pocket right now. Yeah? So every mobile phone can be turned into an AR device. So that makes it much easier to use. But it has limitations also. The size of the screen, for example, yeah, it's not immersive, which can be great because if you can realistically project your hand on your own desk or next to your real hand, it can probably be very powerful, but it's not that easy yet, and it will be also maybe the distraction, for example, effect that is a side effect of VR and won't be there. So I've seen papers on CESCOM which showed and that you can do amazing things with AR, but I think that more research is needed also to understand the mechanism that will play a role there.
It could be a good solution for amputees because they don't have the limb. So we can induce some kind of embodiment with augmented reality. But for example, with other pathologies, it's difficult to create an embodiment, a full embodiment illusion with augmented reality. Instead, with immersive virtual reality, it is possible to fully embody people in a fake avatar. So this is the difference. Depends of the patient and depends of the case. Augmented reality can be also very powerful.
Yeah, also the tactile feedback in AR is, I cannot imagine how we could simulate tactile feedback for an AR projected arm. So, for example, so this is a serious limitation.
Okay, thank you very much. I think we take one more question, and now we change tracks completely to a more, well, definition question. The idea, and that is the question here now, the idea behind using bodily illusions for pain relief is to resolve the sensory-motor incongruence. What do you think is the actual mechanism that makes pain arise from the incongruence, and how would you explain phantom limb pain with late onset arising years after amputation?
Okay, yeah, we have to make more studies to investigate this effect indeed, and with different types of patients. But the idea, yes, is to resolve this sensory-motor conflict, but not only, also to resolve the perception of the body, the representation of the body in the brain, as I said. So one thing is the sensory-motor incongruence, that is that the effect that happens with the mirror visual feedback therapy. It is a thing, and it could work to resolve this incongruence, the mirror visual therapy, and to modulate the distorted representation of the body, giving some coherence to this alteration of the sensory information. But another application could be to modulate the distorted representation, this maladaptive plasticity of the amputated limb in the brain, or the preserved representation of the amputated limb in the brain. How can we modulate this with by using body illusions to modulate the distortion, to make it disappear? This is another type of application. And of course, we need more studies to investigate this, and also to combine these studies with maybe fMRI techniques to know what which is the impact, the real impact in the brain network. No? So this is the idea. I don't know if Tony or...
Yeah, I would probably add that I think there probably isn't a single mechanism for phantom limb pain, and some are probably more centrally driven, and again, we're not clear what the mechanism there. Some may be more peripherally driven, which means that unfortunately there isn't going to be a magic bullet in terms of treatment. So we know that some treatments work well for some people, who don't work at all in others, or worse than others, and the same is likely to be true for bodily illusions as well. I think it's such a complex and heterogeneous problem. It's described as a snake with many heads, isn't it? Chronic pain, so and phantom limb pain as well. So yeah, I don't think we're going to find the magic bullet. I think there's going to be lots of potential mechanisms at play. It's highly complex.
Thank you so much for answering all our questions, and now I'm handing the word over to Professor Dr. Max Ortiz-Catalan.
Thank you.
Thank you.
Man, I hate going after you. Well, just want to say thank you very much for your participation today. There are many points on your presentation that I would like, and many others here would like to debate. So please join us later on the panel discussions. I think one of the main objectives of this conference is precisely to discuss some of those, what seem to be now very grounded ideas on the field that I will argue have a bit of a shaky basis. But I appreciate that you were realistic on the therapeutic effect and the limitations of many of these technologies. So thank you. and we will see you throughout the day and at the panel discussion. Thank you.
Thank you.
Thank you.